Data looks like, do you see my data? Yeah?
Mm-hmm.
Okay. So everybody has a data. Um, First, I want you to look at variable view, then look at gender and change that to string if it's numeric, and make sure that that's a nominal data type here. Then one thing that I want to show you though, gender, they actually, what is it? They collected a sex, not actually gender. And you want to know which one is zero, which one is one. They assign the number. Then you can look at that. You can click. Oh, let me just go back here. Click the male and female and click little square. Then you will see zero is male and one is female. And you can also assign like that too. Let's say this one, day one, that data. Zero means what? What is it? Zero means you smell like. Do you? You smell like a corpse. Smelly, right? Extreme use extreme smell. Yeah, smell like corpse. Then you can add it. Then you're adding that information into it so that you can keep what that scale means. And then that's the way to modify here values. Got it? That's the way to use it. All right, having that said, I'm going to go back to the data view. Then we know zeros are male and way down ones are female. So now we're going to do same time creating syntax file as well as creating doing the analysis for outliers and the statistics, the assumption test. So go analyze descriptive stats, then explore first, and then click that. Then you will see. Do you see my dialog? With the variables on the left? Yeah, okay, good, good, okay. Then move hygiene day 1, 2, 3, all to under dependent list. Did it? If I'm going faster, let me know. Yep. Then statistics. Do you see another dialog popped it in? Do you see my screen? Oh, good. Sometimes the Zoom doesn't do it. And descriptive checked already. Confidence interval for mean, which means mean score comes it out of this sample, but your confidence level to apply this one to the whole population, 95%, it'll give you lower bound and upper bound, right? Then I want to check outlier. So check outlier. Then say continue. Did it? Then we will click plots to see what options we have there. And I click the stem and leaf, which does box analysis, histogram, so that you can visually see the normal distribution. Then I will check normality plot with the test. This is the one actually does KS test and those statistic tests for the normality. Then say continue. Are you with me? Then now options. This is important. Oh, you have a missing. What are you going to do with it? And because the day one, they collected 800 or something. Day two, they missed a lot of first day participants. They missed even more on day three, right? So what are you going to do? Exclude cases list-wide or exclude cases pairwise or report values, and you can add values. But let's have understanding of what the list-wide versus pairwise. Anyone has an idea? List-wide? List-wide, get rid of it. So if 3 days, one has a missing, then list-wide, get rid of it. Whole case is gone. That's a list-wide exclusion. Got it? Pairwise, whenever you do the analysis, if you're doing day one as a group, then you use it, although it has a missing in day two and three. When you do day two, get rid of only the missings in day two. When you do day three, get rid of only the missings that exclude only the missing data there, which means pairwise. Pair, getting rid of strategies with your analysis. Got it? List-wide means if the one case has A missing, get rid of whole list. But pairwise, pair that with the analysis. So whenever you have a missing and that analysis, detect that missing, get rid of it. Got it? So we're going to do pairwise. Otherwise, we end up having 100 or something per every day. We want to use 800 the first day though. Okay, that's why I'm using pairwise and continue. Bootstrapping. Do you see this bootstrapping? That's the one that I talked about it to remedy a lot of assumption issues. We're not going to do it today, but we will do it with the correlation next week. All right, no, following week. Then display, you just click both. Then now, instead of saying okay, if you say okay, it's going to analyze the data and then give you output. No, no, no. I'm going to do what? Click paste. Then you will see, what is it? My output. Do you see it here? This one pops it up on the top. I have a whole lot more up there. That's why it's popping up on the bottom. But you will see another dialog open up for you, a syntax file, syntax editor. Do you see the syntax popped it in for you? Then save it, file, save as with, match your file name with your data name. Do it and save it now. I'm going to save it as a lecture 3 download festival syntax.sps. Save it. Oh, it's the same thing. Yeah, I saved it. Save that syntax file. Once you have a syntax file, you will see me now keep adding to this. Okay. So now we are doing first one, the highlighted like that using mouse. Having mouse is key. Okay. In SPSS, highlight it and then go to this green arrow, which is run stats symbol, run it. Okay, it ran it. So let me see.
Dr. Kim, what did you highlight?
The analysis that when you say paste, this one came out from your clicking into your syntax, you highlight it and you just run it. Okay, so I ran. So I'm gonna go to my output. So this is output. Do you see my output dialog? Yeah, okay. Oh, this is cool. I don't have to switch it around. You see my, okay. So I used to like switch it around my dialog box. Okay, here we go. Here, data. Okay, let me, how do I make this one looking bigger? Can you see okay, my screen? Yeah, okay. So total number of N, 810 for day 1, 260 for day 2, 123 day 3. That's N, and then some percentages there, blah, blah. Then descriptive now, highs in day 1 with 800 people, mean score, then lower bound, upper bound, confidence interval. Then go down here, skewness and kurtosis. Look, skewness is 8.86 and kurtosis is 170. If this one is higher than what, then we need to be concerned about normality. Do you remember that? The kurtosis and skewness number, if this number higher than what? 3.0. If it's a higher than 3, we need to be concerned. And this is huge, means day 1 has some problem right there. We detect the 1. Going down, highs in day 2. Skewness, kurtosis, okay, mean score is here and everything comes up, but skewness, kurtosis, it looks okay. You see that, what I'm seeing here? Day 3, is it okay or not? If it's okay, thumbs up. Normality, yeah, exactly. All right, now extreme value. This is outlier that we clicked in descriptive. Day 1, highest 5, lowest 5, right? Then highest 5, case number. Case number actually is a number that you will see on the data sheets on the left, okay? Look, case number 682 has a value of 20. What was the response range? Was it 0 to? Based on the data, what was the response range? 0 to 0 is you smell like a corpse.
0 to 5.
0 to 5 or 4?
Or 4, sorry.
4, right? Then there is a 20. Detected outlier right here. All right, going down, Number two, so before we do central analysis, this is what we need to do. Central tendency, like a mean score stuff, okay? Day two, do you see anything extreme? Highest, lowest? It all falls in between 0 to 4. Looking good. How about day three? Good. Got it? All right, going down. Normality test, KS test, and Shapiro-Wilks test. Ooh, significant. Significant means they're not normally distributed. So we are gathering visual and skewness, kurtosis, small stats, and the actual normality test. It conflicting, right? Day 2 and 3 were okay up there, but here it says it's a non-normally distributed. Okay, keep going down. Histogram. Day 1, very like kurtosis is very high. That because of that kurtosis was what? 170. I mean, we don't want to have that number higher than 3 and 170. Look at this one. There is one data point at 20. Do you see that little one bar, the blue? That was that outlier. Do you see that? Okay, going down. This one's supposed to be together for normality test. It's going together, but look at this one here. Outlier is right there. You detected it? Okay, going down day 2. Oh yeah, even this is a box plot. Box plot comes out with the data that goes out of range. If it's a circle, it tended to be okay. If it's what? Star like this with a case number here, this is true outlier, confirming that there is one outlier, case number 682. This is day 2, skewed a little bit, but skewness kurtosis value was okay, right? Keep going down. Oh, when you look at QQ plot, it's not like together. Visually a little bit worrisome. Then, oh, okay, box plots, all circles, but some of them are out of a box. Are those outliers? If you end up wondering like that, then you need to go next step, which is Z test, which I will show you how to do it. Okay. Day 3, skewed again. Then when you look at their the QQ plot, oh, not together like this, right? Supposed to be together. Then when you look at box plot, there is one person out of a box. All right. So you have a data point. Now you need to make a decision. So when you're going through this, all right, case number 682, what if I get rid of it and then redo the analysis? Right? That's the one thing that you can think of. Other things, oh, I have some variables in day 1 and day 2 and day 3 1. Case like this, 789 case number out of a box. I need a Z-test, Z-score to examine truly whether those are outlier or not. That's the decision that you're making, okay? So, question so far? Okay. Somebody hands up? All right, unmute yourself. Ziggle, you said
Oh my
Ziggle.
gosh, I don't know why that's, sorry, I'm on a different computer. That's funny. Are we supposed to all be able to look at this? Like, should our program have computed the same thing?
Oh yeah, absolutely. That's why I want you to do it. All right.
No, I know I filled in everything and I pasted it and did the green play button, but mine didn't compute to this.
Then there is a something. Did you open the data? Do you have your data open?
Yes.
Okay. Can you share your screen with us?
It's on a different computer because I can't see it when you share your screen. I can't access the other document. So it's on a different computer.
Okay. Your data is open, and then if you did click the way I clicked it and paste it, then you should have it. Let me just reopen up. Here we go.
You have to highlight it.
Highlight like that.
So I highlighted it and then I did the green button at the top. Yeah.
And if
then what?
Yeah, if you run it, then you will have another dialogue that looks like it says output. So you have to open the dialogue. So when you're running this, you will have data, you will have log and output and syntax, multiple boxes. So go down on the bottom.
I found it.
Yes.
There it is.
Yeah, here
Sorry,
we go.
thank you.
No, that's okay. Next time you're not going to ask that question. It's SPS thing. All right. So now we have two things, 682. I want to get rid of it and then see how it looks like. Then here, I'm going back to my data. So that's another strategy that I am particularly emphasizing. This is the original data. Then you will go down all the way 682. Tick, tick, right there. Do you see that 20 right there? Right? So I want to get rid of this, but you're now manipulating data, right? From original one, then you do not manipulate directly to the original. What I ought to do, that's my strong recommendation. Always keep the original data. As you keep manipulating, changing your data set, later on, if you lose your track of what you have done, you don't have original data. Okay. So let me share with you one thing. Do you see my PowerPoint right now? I moved it to the shared screen. Yep. I intentionally put. Do you see my Google Drive? This is, look, schema variety. That's my original data. Then I say schema save. No, schema variety is my, first one is my, what is it? This one, the syntax file. My first data is this one. All right. Then number 2, outlier removed. Do you see that? Save it as outlier removed. Then and then go down again, outliers removed. Then Amos, which is different analysis. I'm keep saving depending on the purpose of my analysis. So what I'm trying to say and emphasize, which is a very important skill, keep original data. Okay, so that if things go viral somewhere, then you have a place to come back. Okay, so if we want to, I'm moving this one away. So now we want to get rid of 682 because of that outlier. And then to me, it's a human error. It could have been 2 point something. I mean, truly, person cannot put 20 because response rate is 0 to 4. So you can say it's a human error and you decided to remove it. Then I save it as, then I say outlier removed and save. So now it's a different data set. This is not my original. Then I'm going to get rid of it.
I have a question.
Sure.
How do you get back to, so after you've ran like your data here, how do I get back to my original data sheet? This like
It should be open right there.
Oh, it should be open?
Yeah, it's a multiple dialogue open. So go down to your the SPSS symbol bottom there, then you will see how many dialog boxes are open. So I have output box there, data box there, sometimes multiple data open there. So you need to ensure that your syntax file analyze correct data sets, okay?
I can see it. I got it.
Yeah,
Thank
yeah.
you.
So that's the way to, yeah, it'll come along. So then I go back to here. Then I want to ensure I don't have more than one data set so that syntax file understand I have only one data. Then I'm going to go back to my, I'm going to get rid of this results for now so that it's simpler, all right? I'm going to rerun without that outlier, okay? And boom, I did it. Then it's on output, it came out. So you will see it's here, 809, right? It was 810, so I got rid of it. The rest of them same. Look, skewness and kurtosis here drastically drop down. So that outlier was the problem. It's clear, statistically clear. Conceptually doesn't make sense because no one could say 20 out of 0 to 4, right? Then number 2, day 2, day 3, all same. Extreme value, day 1, now it's gone. You don't
Dr.
see
Kim,
yes?
really quickly, I think I didn't catch when you deleted the data, but how did you delete that one outlier?
Same.
That's okay. I just clicked here, then delete. Yeah, it's that simple. There are a lot of little tricks. It's going to come back. Yeah. Then I saved it as what? Outlier removed. so that I keep the original data just in case I want to go back. Okay. I mean, when I deleted it though, what did I do? I used list-wide or pair-wise. I got rid of whole thing. You could have just deleted only day one. It's up to you. It's a researcher's decision. Got it? Okay. Then I go back output. Then keep going down. Test the normality. Oh, look at this day one. Do you remember day one how it looked? Like this? Then 20 was over there. Normally distributed. Then look, they're all together except the tail a little bit, which is good enough. And this is good enough. It doesn't show any patterns. Oh, so yeah, right above that range, I'll just take it. Day two, little skewed. Oh, doesn't look like normal. It has some outside the box number of them. Okay, let's do some Z-scores for day two to see whether they are okay. Okay, so how do we do Z-score test? And the three are all same. So we want to do, okay, now since we have some cases out of a box, let's do some Z-score test. So we can start right here with analyze, or you can go back to data. Oh, I want to look at the data when I do analysis, then that's fine. Go back to that data sheet, then analyze. Do you see that? Then I'm going back to descriptive now, which was descriptive. Last time we clicked explore, but this time we're going to do descriptive. Got it? Then I click that. Then I put all hygiene moved here, right? To under variable list. Then I checked this one, save standardized value as variables. You just click it, mark it like that, right? Then let's see, options. I want to have a mean score, standard deviation is good enough, minimum maximum is good enough. You could do kurtosis test and skewness test here too with the descriptive, but we don't have to because we got them already. And variable list, that's fine, continue. And bootstrapping is here too. We don't have to use it for now. Style, you don't have to worry about it. Do we say okay or paste it? Paste. Yeah. Then go to your here. Then look, paste is right here. Then I'm going to add a note to it. Okay. So here I'm going to start. Then I say we decided to remove case number 682 because of its extreme value. Then period. Then do you see that this note got graded out? That's your note. So start with asterisk and put your notes and period and at the end, it all grays out. Then it's your information. It doesn't run anything. It just keeps some notes in there. Then here, I could say same thing, star this descriptive stats is based on no outlier data set, period. Then it's a note. Then I have descriptive right there. Got it? So always like, I mean, sometimes you can say, my advisor says, get rid of this because of that IDs and that. You have to put that in there. Otherwise, your advisor later on, did you get rid of it? Why? Then you say, I don't remember what you said, but you have your notes right here. Dr. Lee says to get rid of those outliers because of this, and then I removed it. I repeated analysis. Those are all good notes to go in here, okay? So that you don't forget dialogue of your decisions on your data. So now I'm going to do run, highlight it and run. Then go back to my output. Then I see the standard, descriptive stats right here. However, I want to go to your data. Do you see that? New data popped it in, which is this. Yeah. This is Z-score of day 1, Z-score of day 2, Z-score of day 3. Then There is a complex way, but I learned the simpler way. Just click this, right? We want to detect any cases that with the G value above 3. I want to detect that. So highlight it, just click on the top, right click over your mouse, then descending, then highest number will be on the top. Only day 1 first. I don't have anything. So, oh, okay. So no outliers here. Got it? Yeah. Then let me see. Day 2, click first, then right click, descending. Oh, I have about 3 of them. Maybe 1, particularly, maybe first 2. Should I be worried about it? Yeah, you can pay attention. I mean, but their response rate is within 0 to 4. So you make a decision. It falls in the response rate, and then I decided to keep it. It's a researcher's decision. How about day 3?
Excuse me, Dr. Kim.
Mm-hmm.
I'm confused on how. Oh, I guess because you have a lot of data. Never mind.
Mm-hmm. This data came out because of the analysis that we did. Going back, how did we get this? Go to descriptive, then click that save standardized score as variable. Then you run it. Then this one pops it into your data sheets. Okay. Then when I click this, I have only 1 data. When I see this, you decided as a researcher whether you're going to keep it or using z-score, you get rid of it. All right. It's a big decision as a researcher. So that's the one to do it. Outlier test and z-score test. All right. Now, questions before I move on how to do group differences of this one because it's relevant to step 3.
I have a question, Dr. Kim.
Sure.
Is it any different or is it wrong if we did not paste it? Would the results be any different if we just ran it? You know how you...
It's the same. It's the same. It's the same.
Okay.
Yeah, it should be same. If anything is different, then maybe what you're clicking and what I am clicking could be different. So I click the same thing, and then I'm telling the computer program create the syntax so that later on, all I need, if I want to have descriptive here, I just run it again. Or let's say, if you get used with this programming file, later on, you don't even use click. You just copy paste it from here and get rid of day 3 here. I want to just day 1, day 2. Then get rid of day 3 and run it. Oh, I want to bring that day 3 back in. Then back in there and then do it again. And then that's what you will do. A lot of copying, paste, and writing directly. Some advanced stats, even MANOVA, particularly at MANOVA level, there is no clicks. You have to write up. So learning this will take you to the advanced stats, which is up to MANOVA only. But even beyond, textbook will say, paste this syntax into your syntax file, not clicking, because it's advanced and it gives you programs, not clicking procedures. Okay, so that's what you're going to use. All right, any questions so far before I show you how to split, how to do this, what we just did by group?
Dr. Kim, just to clarify, so everything we're adding on this syntax file is for our reference at a later time.
Yeah.
Like with the
Then
copy and paste.
exactly. Then you go back to there. So here, this analysis, when we did the first time, we had outlier. Now in the data file, we got rid of outlier, and then now we have a new data set. And instead of clicking again, you just run it from here again. So you're basically saving your analytic procedures into the program so that you can reuse them and or you remember what you did. That's the key to me. Like you remember what you did, a history of your analysis. And in my syntax, the other ones that I don't have it here, sometimes I do that, like 5-page long syntax file. Then around here, I say, this analysis was done for S conference. Then I know what analysis, how I did for a conference paper. Otherwise, you're not going to remember all those multiple analyses with your data. Okay, so that's the way to use this syntax. And like I said, repeating, later on advanced stats, there is no clicks. You have to be able to write up like this. Okay, so that's why we are studying. So before I say goodbye today, I know you need a break. I can tell from your eyes. I want to show you how to split the data, and that's a very simple one, and unsplit it. Then do the same analysis by group, which is gender in this particular one, and that's a stat 3, okay? Stat 3, I ask you certain things to do by gender. So how to split the data if it's needed. It's a small skill, but very important to know. Go to data. And then on the bottom here, do you see that split file? Yeah. Then analyze, compare the group. Then I already moved the gender to here. Okay. Then instead of doing anything, what do? Paste it. Then you will see on the bottom. Okay, let me just go all the way up here. Yeah. Program came out. Then now you need to run it though. Run. Then now your dialog says, okay, it got split. So if you do analysis from now on, you will see by gender, male first, female bottom. So it's separate, okay? And okay, I want to combine them together as a whole. Then go back, same place, split here. Then and you say on the top, go back top, analyze all cases, do not create group, and you paste it. Then you will see on your, do you see that? Split file off. It pops it up on your syntax. Run
Can you
it
do
again.
that again?
Yeah. Okay.
Please.
I'll do it again. All right. So splitting here. Go here. Data. Split file. And compare groups. Okay, let me just move this one back. Then I want to compare groups by gender. Move there. All right. Then paste it. Do not just say okay, because you lose track of the treatments to the data, right? So I'll say paste. Then it'll pop on your here. Do you see that it popped it up? Then highlight it, run it. Then it's split now. Here, it's split it. Now I'm gonna turn it off so that it can be one, so that I can analyze it as a whole thing. Then go back data. Then go to split file again. Then instead of compare groups, go on the top back up here. Then you will turn off the split. Then paste it again so that you have a track of what you're doing. Oops. Okay, here. Where did it go? Okay, here we go. Then run it again. Highlight, split file off, highlight it, run it. Then it's turned it off. So when you analyze it, it'll analyze as a whole group. It's great to have a particularly exercise physiology, movement science student. You have gender data, then you have exercise group data, and you want to compare separately and all that, then you can split the data so that you can do separate analysis by groups. So that's why I'm giving you a little trick right there. For home, the step 3, I ask you by gender, what we just did. Okay, the outlier test and the normality test and all that. Go to analyze the same thing, okay, and descriptive same thing for to do the analysis of what we have done by group, by gender, sex. Go to explore. Do you see that all 3 here? Now move gender to factor list. Got it? And I'm going to show you how it looks like. And then statistics all same. Continue. Plots the same. Continue. Options same. We're going to use pairwise. Continue. And paste it. Then you will see the program syntax file. Right? So then I'm going to highlight this and run it. Ta-da. Then here, gender 0 means what? Male. 1 is female. Day 1 here. Oh, let me just start up here. Day 1, 0, 1, 0, 1, 0, 1. So it's now giving you the data by gender. Got it? Then festival 1, descriptive. Now kurtosis and skewness, Look, 0 is male, 1 is female. Male, female, both are okay. Okay. Then day 2, 0 male, 1 female. Okay. Oh, it's a little bit higher here, 3.1. Maybe not that concernable, but it's a little something to pay attention. Female is okay. Day 3, kurtosis, fine for male. Female, fine. Extreme values for male, highest to lowest on the first day, and female, highest to lowest. Keep going and detect whether there is anything that you need to concern about your data. The normality test here. First day, second day, third day, male and female, all significant except one group actually. Do you see that this is not significant? The first one, male group highs in day 1, right? Not significant means it's normally distributed. Other than that, all significant. All right. Histogram, this is by male, gender is 0. Female, pretty similar. Okay, male is good. Female, oh, at the tail, there is a little problem, huh? That's why that number was a little higher. Then keep going. Male, female, they're okay, they're giving you both. Oh, male has a little bit more out there that you need to pay attention. Okay, this is for male, skewed, female, skewed, a little better than male. This is a way to look at it. Okay, so oh yeah, this one is even worse for gender female, a day 2, and then keep going down. Whenever you have start in the box, start number, oh, there is one, 57. You need to pay attention to this right here, which is male, day 2, 57. And then what do? Z-score test, and then you make a decision as a researcher. Okay, so having that said, I am going to go. I'm moving here and I'm moving this one out here so that I can keep recording it. Step number 3. Do you see that step number 3 here? Yeah. Okay, so what you're going to try here. Number 1, describe the participants. So you have data, so you need to describe it the way that they described it, okay? And the central tendency, variance, and standard deviation of day 1, 2, 3 by gender. Got it? Then you need to split the data or do the gender as a group and analyze it data. Detect the possible outlier in the data all 3 days using plots, z-scores, and then based on your speculation of the outlier test, report your findings and decisions if you end up removing it. Let's say you did this. So before you do this homework, this is the thing. There is no step-by-step analysis. Some students do this one first. Then they do number 2, then they got rid of 682. If you get rid of one data, do you have to redo this one or not? You have to redo this again because you got rid of data and then you have to recalculate mean scores, right? So when you read the questions, you make the decision. Okay, I'm gonna do this first. I'm gonna do this second. I'm gonna do this third. This is not elementary stats for like undergraduate students. Step 1, do this, step 2, this. No, I throw the question to you. With the data, you decide the steps, how you're going to report. So if you do this one first, and then you got rid of outlier, you need to go back to number 1 because this will be final report of day 1, 2, 3 by gender. You're not going to report to separate different data set here, right? Okay, good. Then conduct a normality of data provided using skewness and kurtosis and KS data and report your findings. How do we report? Where do I have that? Here, outliers. This is the example that I'm giving you. Sometimes just go with the other people saying it until you develop your sense of writing. Then skewness, kurtosis. You need to report the mean, standard deviation. Then this is skewness, and then SE is right. This SE that you can find is right. It's standard error that I'll give you a concept later on. You need to pick that up from let me start here. Skewness, kurtosis, that's the number. Then do you see that standard error? That's the SE error that you're reporting in writing. This is what you need to pick up. That's what I'm talking about. This is skewness with a standard error. Then kurtosis, number that you pick up from there. Then and then right hand side, you will see standard error right there. How to report KS output? It's on page 191. You will see me if you don't follow what they're saying there. Then I will say in my comment, look at field page 191 multiple times until you correct it. So statistic, stat number 3, it's until 1, 2, 3, 4. Sums are as a whole thing, sums are by group. And some may require you to create table to report. Some you'll be okay within the writing itself. And if you want to include a little bit of that QQ plots to describe, then you know how to cut it out, right? Copy paste it, or you can cut it out using what is it? That little snipping tool.